Okay, so in this video, I want to focus on the moment of inertia. So let's see, in the last video, I told you that the moment of inertia for one mass, like this setup here, is I equals mr squared. But what if you have another mass? Like what if you had another mass here, and let's say you had a mass here and a mass here? You could have a distribution of masses. Like you could have a wheel with an infinite number of infinitesimal masses, and then you have to add up all of the little itty bitty masses, and then it turns into a calculus problem. So anyhow, we're not going to go there, but we need to talk a little bit more about how to figure out the moment of inertia. So let's take a look at that. Let's go back to something that we covered before, center of gravity, because moment of inertia is going to be very similar to the center of gravity process. So when we found the center of gravity, let's say let's just find the x location of the center of mass. Okay, center of gravity and center of mass, they mean the same thing. So that's what I meant to say. Okay, so the center of mass, the x location of the center of mass, let's say you have more than one mass. Let's say you have 2 or 3 or 4. So it would be x1 times mass 1 plus x2 times mass 2 plus, and then this could keep going, right? And but you're going to need a denominator here. It's going to be mass 1 plus mass 2 plus mass 3, right? And so on, right? Plus dot, 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 goes on and on. Now, the way you would write this in a mathematical shorthand would be like this. You'd say x center of mass is equal to the sum of x sub I, m sub I, and then, but this also you still have to have a denominator, the sum, right? This was supposed to be a sigma, m sub I. So that would be the shorthand way of writing the center of mass. Don't forget that there was a y center of mass, and then and so on. Okay. So now let this shorthand here, what this is telling us is to find the moment of inertia, we're going to have mass 1 times its distance from the rotation axis squared plus mass 2 times its distance from the rotation axis squared, and on for as many masses as you actually have. Now, in this example, we've got 2 of them. Right? So I've got barbells, so I'm holding these things up, and we're going to ignore the mass of the stick that they're on. We're just going to consider the 2 masses at the end. So what is the moment of inertia if they're both 20 kilograms and if they are 1.6 meters apart? So we didn't say it, but the rotation axis would be like this. And right, so the distance from the rotation axis is half of 1.6 meters. It's 0.8 meters. So to kind of analyze this problem, you want to put the masses, represent them by dots here, and they are 0.8 meters away from the rotation axis. All right, now we can do it. We can put in our formula, which I started writing down over here. It's mass 1, which is 20 kilograms, times the distance from the axis, 0.8 meters squared, plus mass 2, which is also 20 kilograms, times its distance from the rotation axis, 0.8 meters, Now you could say, I messed up a little bit. I should have had a negative sign here, but it doesn't really matter because we are squaring it, and that blows away the negative sign. And do the arithmetic, and you get 25.6 kilogram meters squared. All right. Now, I would like you to print out this page of the notes, page 9 of the notes, because it's a worksheet, and I would like you to try this yourself. Figure out the center of mass of these things and figure out the moment of inertia for the same configuration. And you probably don't want to do this, but I really recommend that you do it because this isn't, it's easy to get confused. You're going to get messed up, and making mistakes is the way to learn. You're going to see the answers later on. So print this out and do the work, and then check your answers later on. Okay? Thank you, and goodbye.